Picture yourself in a wartime design office in Hamburg, 1941. Bombs are falling on European cities. The Atlantic stretches like an impossible barrier between two world powers. And in the middle of all that chaos, an engineer slides a blueprint across the table and says, "We're going to build the biggest flying machine ever to touch water." That was the ambition behind the Blohm Voss BV 238, a project so colossal it reads more like science fiction than wartime engineering. Now, if the name Blohm Voss rings a bell from naval history, you'd be right. This was a Hamburg shipyard, steel hulls, submarines, destroyer escorts. That was their world. Aircraft design. Completely foreign territory. But when the Reich Aviation Ministry came knocking with a vision for an ocean-crossing transport aircraft, the company stepped up without hesitation. The mission was straightforward, at least on paper. Build a flying boat capable of hauling enormous payloads across vast stretches of open ocean. Not just a seaplane, but something closer to a floating fortress with wings. The aircraft would need to take off from water, carry troops, vehicles, or supplies, and fly thousands of kilometers without stopping. It was, in essence, a ship that could fly. What emerged from the drafting tables would become the largest water-based aircraft the world had ever seen. Lead designer Richard Vogt and his engineering team faced challenges on every front. The fuselage had to be structurally robust enough to withstand the stresses of open water takeoffs. Essentially, it had to function as a ship's hull. The wings had to be enormous, and not just for lift. They needed to be thick enough for maintenance engineers to crawl through during flight to service the 6 massive engines mounted along the leading edge. And all of this was happening under constant pressure. Hamburg was being bombed regularly. Raw materials were scarce. Every sheet of aluminum had to be justified. And as history has since made painfully clear, some of the labor used in construction came from forced workers, a shadow that hangs over the entire project, and which Blohm Voss later acknowledged through compensation programs and a memorial erected in the workers' honor. Despite all of this, they built it. The BV 238 V1, the first and only completed prototype, was staggering in scale. Wingspan, 60 meters. For context, that's wider than many modern commercial airliners. Length, 43 meters. Maximum takeoff weight, nearly 100 tons. Power came from 6 Daimler-Benz DB603G liquid-cooled engines, each producing around 1,900 horsepower. Combined output exceeded 11,000 horsepower, enough to drag nearly 100 tons of aluminum, fuel, and cargo off the surface of a lake and into the sky. Cruising speed sat around 300 kilometers, with a top speed of roughly 350 kilometers. Neither figure is remarkable for a military aircraft, but the BV 238 was never meant to be fast. It was built for endurance. Its operational range reached approximately 7,000 kilometers, enough to cross the Atlantic with payload to spare. Beyond the sheer size, the aircraft contained a number of surprisingly sophisticated design solutions. The most visible challenge for any large flying boat is water resistance during takeoff. Standard seaplanes of the era used fixed outrigger floats mounted on the wingtips or fuselage sides. These worked, but they created drag and handling difficulties. The BV 2038 used a different approach. Retractable side floats that folded up hydraulically once the aircraft was airborne. It was among the first large flying boats to achieve this, and it made a meaningful difference in aerodynamic performance once in the air. The flight control system mixed hydraulic assistance with direct mechanical linkages. Hydraulics handled only the heaviest control loads, while elsewhere the pilot maintained a direct physical connection to the aircraft's surfaces. A deliberate choice that kept the system simpler and more reliable. The wing flaps were fully integrated into the wing structure rather than bolted on as external additions. They deployed flush with the wing surface, reducing aerodynamic drag and improving handling at low speeds during takeoff and landing. The cockpit featured modular window panels that could be replaced individually, useful for eliminating nighttime reflections and for rapid repairs. One side window could be slid open manually by the pilot, requiring no power and offering a direct emergency exit if needed. Ventilation used passive airflow channels positioned just below the cockpit windows, drawing in outside air through pressure differentials alone. No fans, no compressors, just smart placement. At the nose, Two measuring probes gave the pilots accurate airspeed data even at low altitudes over open water, where air pressure behaves unpredictably. One measured dynamic flow, the other static pressure, combining to filter out the distortions caused by wave-level turbulence. The nose itself could open, hinging upward or sideways like a cargo door, providing direct access to the lower deck for loading long or awkward items. Above it, the crew occupied two full levels, making the BV-238 one of the few aircraft of its era with a genuine split-deck interior layout. A crew galley with refrigeration was included in the plans. This wasn't a luxury. On missions of 7,000+ kilometers, crew welfare was an operational necessity. To understand just how ambitious the BV-238 was, consider the competition. The Hughes H-4 Hercules, the famous Spruce Goose, had a larger wingspan, but flew only once, briefly, and never carried a meaningful load. The Japanese H8K flying boat was a capable, combat-proven aircraft, but it was roughly half the size and weight of the BV-238. Even Blohm Voss's own earlier design, the BV-2122, was substantially smaller. The BV-238 wasn't just the largest flying boat of its time. By most measures, it was the most ambitious aircraft construction project of the entire war. Inside the Blohm Voss design offices, the V1 prototype was only the starting point. Detailed plans existed for a full series of follow-on variants, V2 through V6, each with progressively more powerful engines, greater payload capacity, and refined mission profiles. The V2 was well along in construction. The V3 was slated for BMW power plants. The V4 was designed around a maximum takeoff weight exceeding 104 tons, heavier than any aircraft then in existence. Interior configurations included a troop transport version capable of carrying around 300 soldiers, with a center aisle and bench seating along the fuselage walls. Other layouts included dedicated cargo configurations, medical evacuation variants, and even a theoretical long-range bomber capable of carrying multiple large munitions. That last idea was never seriously pursued, but the documentation exists. The level of planning detail, serial numbers, factory specifications, scale drawings, deck-by-deck interior layouts, suggests a team that genuinely believed this program had a future. On March 11, 1944, the BV-238 V1 lifted off from the waters of the Elbe River near Hamburg for the first time. Test pilot Helmut Wasserheli handled the controls. The flight was largely uneventful. She climbed, flew steadily, and came back down without incident. A successful debut for the most complex flying boat ever constructed. After initial tests, the aircraft was relocated to the Schalsee, a remote lake offering calm water and distance from the increasingly intense Allied bombing campaigns around Hamburg. There, she conducted further water trials. Plans for operational missions were drawn up. Long-range supply runs to North Africa, logistical support for Scandinavian operations, even a potential role as a mobile resupply platform for submarines operating deep in the Atlantic, delivering fuel, spare parts, and provisions to U-boats far from any port. None of it happened. In May 1944, Allied fighter aircraft, reportedly American P-47 Thunderbolts, located the BV-238 V1 on the Schalsee and attacked. The aircraft was strafed and sank. The V2 airframe, still under construction, was destroyed to prevent capture as the war situation deteriorated. And with that, the program ended. The largest flying boat ever built disappeared beneath the surface of a German lake before it had flown more than a handful of times. The surviving design documentation, some of it still held in archives today, is a record of what might have been. An aircraft that in peacetime might have pioneered transoceanic commercial aviation, and in wartime simply ran out of time. Blohm Voss returned to building ships. The engineers moved on, and the BV-238 became one of aviation history's most extraordinary footnotes. The biggest, most sophisticated flying boat ever constructed, lost before most people even knew it existed.